Hi guys, this is Miss B again here. So today we're going to be going over 13.1 exponential growth functions, okay? So first we're going to start by defining an exponential function. This is a function of the form f of x equals b to the x power, where b is a positive constant other than 1 and x is a variable. Okay, I apologize if my handwriting is unreadable. I'm doing my very best with a different format. So I'm also going to define what an asymptote is. An asymptote is a line that the graph can't cross, okay? And so I'm going to explain that when we go over to our graph over here on the right in a few minutes. So what they're asking us to do right here in this box is to complete the function f of x equals 2 to the x power. So we're going to start by plugging, sorry, I got to put it on the pen, 2 to the negative third power, which gives us 0.125, okay? 2 to the negative 2 power gives us 0.25. 2 to the negative 1 equals 0.5. 2 to the power of 0 equals 1. 2 to the power of 1 equals 2. 2 to the power of 2 equals 4. And 2 to the power of 3 gives us 8. So I'm going to use these values to go over to my graph and plug them in. Now, to plug in 0.125, 0.25, and 0.5 would be really hard on this graph. So I'm going to start with 0, 1. Okay, so that starts right here. And I'll actually draw in 1, negative 1, 0.5, just so that you have that as our starting point, okay? And so then I'm going to go 1, 2. Then I'm going to do 2, 4. And I'm going to do 3, 8. And that gives you my graph. So I'm going to draw here. The asymptote, as you notice, is where you can't cross. So your line will continue along this, but it's never, ever going to cross this line. So in hot pink, I drew that the asymptote is y equals 0. So for a basic function, f of x, y always equals 0. So f of x is our parent function. Okay, so we're going to come down here and I'm going to label g of x is our transformation function or transformed function. Okay, and f of x is our parent function. Okay, so parent function is just the original function, okay? That's just what we originally did, and then g of x is what we've transformed it to be, all right? So in f of x, you have our first reference point as 0, 1, and so this is our first reference point, and our second reference point is 1, b, okay? For g of x, okay, it's going to be our first reference point is no longer 0, 1. It's actually h, a plus k, and our second reference point, okay, is going to be 1 plus h, ab, so ab is a times b plus k, okay? And here I'm going to next explain what each of these parts of our equations mean. So a is our vertical stretch or compression, okay? B is our horizontal stretch or compression. H is our horizontal shift. So this means that we'll move either to the left or right. And K is our vertical shift, meaning we will be going up or down. Okay? And for the transformed function, okay, the asymptote, write it right here, is y equals k. And for our parent function, it was y equals 0. Okay? So I'm going to do an example now. All right? So they give us the transformed function g of x equals -3 with our b is 2, x minus 2 plus 1. Okay? So I'm going to list over here my a, b, h, and k, as well as my asymptote. Okay? So a is right here, so that's -3. My b is my base, which is 2. H is right here, okay? So that's going to be 2, okay? So it's always minus 2. So if this was going to be a positive, then this would be a negative over here for our b. You'll see that in a later example, okay? So k is 1. So that means that y equals 1 for our asymptote. Okay, so it's asking me to find our reference points for this transformed function. So my first reference point, I'm going to shorten it to reference point, okay, is h comma a plus k. So I have already listed over here on the right my a, b, h, k, and my asymptote. So I just have to plug in. So since h is 2, it becomes 2. And I'm going to do -3 plus 1. So my first reference point is going to be 2, comma, -2. All right. And my second reference point, the equation is 1 plus h, ab plus k. So I will now plug these in. So I'm going to do 1 plus 2, a, so -3 times 2 plus 1. All right, so I'm going to get 3, comma, -6 plus 1, which results in my second reference point being 3, comma, -5. Okay, so I'm now going to graph this function. Okay, so here we have, I'm going to write my first equals 2, comma, -2. My second equals 3, comma, -5. And y equals 1. So that I have it when I'm drawing my graph. So I'm going to make this as neat as possible, but again, this is on an app, so it will be a little bit harder for me. Okay? So I'm going to only make it up to 1, 2, 3, 1, 2, 3, 4. And please remember that this is a hand-drawn graph, so this is not going to be perfectly drawn to scale, okay? But that's okay. This is just to illustrate the point for you guys, okay? Okay. All right, so I'm going to plot my first point. My first reference point is at 2, -2. So I'm going to go to 2 on my x, and my y is -2. Okay. And my second reference point is my x is at 3, and my y is at -5. So I'm going to go to 3 and go down to 5. This is my second reference point. Okay. And my asymptote is at 1. So I'm going to draw my asymptote in with a dashed line. And I'm going to start from here, and I'm going to draw my graph approaching the asymptote and going on to infinity. Okay, and so that is the first example. So now they're giving us a graph. Okay, for this example, they're giving us a graph, and they're saying use graph to find A, H, K, B, and write g of x. Okay? So I'm going to draw, oops, it's a little too far over. So I'm going to draw the graph that they've given us. And this is done in thirds, so I'm just drawing it how it appears in the notes. Okay, so each of these is a third. Okay, where this is 1. Okay. And it tells me that my first reference point, so they give this to us, they give us my first reference point at negative 1/3, negative 1/3. So this is my negative 1/3 here for my x, and my negative 1/3 down here. So it's going to be right here as my first reference point. Okay, and my second reference point has been given to me at 2/3. So I'll go 2/3 on my x-axis and then down to negative 5/3. So it's going to be right here. And they tell me that my asymptote is at y equals negative 1. Okay? So that's my asymptote. And it looks like this. Drawn, obviously not to scale, but as best I can. Okay? So my first reference point is negative 1/3, negative 1/3. And my second reference is 2/3, negative 5/3. Okay? So from this information, I can find out that my h is negative 1/3. My k is 1. Okay? And I can go in and I can use the equations to figure this out, all right? So I'm going to use the fact that negative 1/3 from my first reference point is equal to a plus k. So since I know my k, I can use this to find my a. So I'm going to say negative 1/3 equals a plus 1, since they told me that my asymptote is 1. So I'm going to subtract 1, subtract 1. And when I'm subtracting fractions, remember I have to make it equal. So I will do 3/3 minus 1/3 equals a. So a equals negative 4/3. Okay, so I'll put that up here. Negative 4/3. All right, and then it wants me to find b. All right, and so they told us that AB plus K is what equals the y of our second reference point, okay? And here they told us that b equals 2, so we don't have to find it. So b equals 2. So I was going off of my own notes and not the written notes. So they gave us that b equals 2, so I don't have to find it. But you can also find it using this, so which we will do in a later problem. So I'm going to write my g of x. So g of x equals my a, negative 4/3, my b, so 2, and then I'm going to do x plus 1/3. Since my 1/3 is negative, it's a plus here, plus 1. Okay, and this is my function. And these are my values. Okay, so for our next example, all right, they again give us the graph and they want us to find the function. Okay, so they give us our first and second reference points. So I'm going to draw the graph, and they give us decimal points on this one to, I guess, give us a little bit of diversity in trying to solve these problems. So 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7, 9, 10, 11, 12. There is much more on the left side of our X as they've drawn for us. Okay. 2, 4, 5, 6. 1, 2, 3. 4, 5, 6, 7, 8, 9. I did not draw my graph long enough. Okay. So this is 10. This is 4. This is 6. This is 12. Okay, so negative 12, negative 10. Okay. So they give us our first reference point at 4. So my X is 4. Negative 4 or negative 4.4. Okay, so negative 4 is my X. So negative 4, comma 4.4 is my first reference point. Okay, so I'm going to go to the negative 4 on my x-axis, and I'm going to go to 4 slightly above 4, and that's going to be my first reference point. Then they tell me that my second reference point is negative 3, negative 10. So I'll put that in here. So that's negative, I did not draw this over my 4. So my 4 is actually right here. Okay, so my 3, negative 10 is going to be 3. Negative 10 is going to be right here. Now, these look almost straight down, and they also tell me that my asymptote is y equals 6. So I'll draw my asymptote. We'll start here, and it goes almost straight down. It's a very crooked line, but you get the idea, okay? So they tell me that b equals 10 here. So I don't have to find b, all right? So using the fact that my first reference point is negative 4, comma 4.4, I can use h, comma a plus k to solve for my my variables I'm trying to find. So h equals negative 4, k equals 6, as they told us that the asymptote is 6. Okay, so I can use the fact that a plus k equals 4.4. So I can use a plus 6 equals 4.4. Subtract 6 from both sides. I get a equals negative 1.6. Okay, and now I can draw my function. So g of x equals my a, which is negative 1.6, my base of 10, x, okay, since my h is negative, it's going to be x plus 4 and plus 6. This is my function, okay? So for our next example, okay, they give us another reference point, and we're drawing our function, okay? So here they give us a graph, okay? And they tell us, oh, that did not need to be that big. It can be that big, okay? So I'm going to do 0 in increments of 0.5. So 1, 2. 1, 2, 3. Okay. And then we'll put 4 right here. And then negative 1, negative 2. Okay. So our first and they tell us that our asymptote is at 5 halves. Okay, so that's going to be right here. So that'll be 5 halves. So y equals negative 5 over 2. So I'll draw my asymptote in. Okay. Our first reference point is at 3, negative 1. So it's right here. And our second reference point is at 4 and 1/2. So right here. So it'll look like this as our function. So this is 3, comma negative 1. And this is 4, 1/2. So this is our first reference point. Okay. So I can say that 3, comma negative 1 is equal to h comma a plus k, since that's the formula. So I can say that my h is 3. And since they told me that my asymptote is negative 5 halves, I can say that a plus negative 5 halves equals, okay, negative 1. So this can also be written as a minus 5 halves equals negative 1. So I'm going to add 5 halves to both sides, okay? So this gives me a, and in order to add this, it'd be negative 2 over 2 plus 5 over 2, which is 3 over 2, or 1.5, okay? So a equals 1.5. All right, so I have a equals 1.5 and k equals negative 5 halves. And they told us that our b equals 2, okay? So they gave us that information, so we did not have to find b. All right, so they should always give you b, since you're not going to be finding that. So our equation, or our function, sorry, is g of x equals 1.5, okay, base of 2, x, and our h is positive, so it's going to be minus 3, plus, or sorry, not plus, it's going to be minus 5 halves, okay? And this is your functions. So these are the exponential growth functions, okay? And so I'll go back up to the top. If you have any questions, please feel free to email me. I am doing this, so these first couple videos are going to be a little rough, but I'm doing my best. So if there's anything that I can do or improve on, please just shoot me an email, and I'll do my best. I'll be announcing the office hours coming soon. All right, I hope to see you guys soon via Zoom. All right, bye.